There are 60 questions in the math test, and there are 60 minutes with which to take that test. Some of them will be faster, some of them will be slower, but you're trying to average around one question every minute in order to see the full test. As a general rule, the first 10 to 15 questions are kind of a warm-up, they're easier. The majority of the test in the middle should be about this one question a minute, and then near the end they throw in the challenging questions so that they can truly say, oh, these people are the ones who are above and beyond and score that perfect score. They purposely make it difficult. Not a lot of people do it, but there are always a couple. So we are going to be starting at question 11, and we're going to take 5 minutes, check in. These were the answers. Again, because it's not the real test, we don't really need to get through all of the questions. We are going to take time to do explanations or questions. And so if I get through 11 through 15 and you're like, what on earth was going with that question 13? I don't know. Then we can go over it and give you the explanation. That time where you don't know but you want to know is the best time to learn. It's the most optimal for it to sink in and stick in your brain because you already have that motivation of I wish I knew. So that is what we will be doing. So first of all is everyone at page 784. Should be the blue book. Do you have that one? Oh, that is the one. Never mind. Sorry, I didn't realize it wasn't blue on the back. I saw the red and it's like, ah.
This is Ava, and I wasn't supposed to be here because I was going to have practice, but I'm here now. So.
Oh, congratulations. Did it get canceled because of crazy weather? Because I hear it's up north. It's a little bit messier than here. Anyway, so the question 1 in the test is in triangle ABC below, but then we're going to turn the page over to 786, question number 11. It looks like in the graph below it's a line graph with a -1 on it. Are we there? Okay. I will set our timer. And you may begin. If you get past the 5 questions, go ahead and move on. Don't worry about that. All right, take pause. If we look back at 11 through 15, 11 was D, 12 was G, 13 was C, 14 is F, and 15 is C. Questions on where any of those came from? 11 was D, 12 G, 13 C. Making sure you guys, yeah, you can see that one. Any questions? Okay, then go ahead and continue. Again, because of how this works, you will eventually start practicing building up a buffer on the easier questions, and then when you need to go slower in the future, it's okay. right, pause and check 16 through 20. Number 16 was K. Number 17 was A. 18 was H. 19 is B. And 20 is K. Any questions on those? Specifically on 18, that's one of the ones I called easy hard. It's not very much going on, but there's a more picture than what you really need. So just be careful of those. All right, starting on question 21, go forward. If you've already made it past 21, keep moving where you're at. All right, checking in, back to 21. 21 is B, 22, G, 23, C as in cat, 24, F, 25, E. Any specific questions on those? '22 is very much a factoring problem. 23, you just have to plug the 3 in and then solve for A. 24 is another easy, hard, extra information problem. 25 is trying to be real world but failing miserably. You would not need that much paint in the real life. All right. Go forward. Starting at 26, if you are not out there already, moving forward where you are, if you are. All right, checking in once more. 26 would be G. 27 is E. 28, F. 29, E. 30, G. Any questions on those? Was there one from online?
I would do the last three.
The last three? All right, so that's starting with number 28. 28. Ah, this one is a good one. I had it marked as one that I wanted to talk about. So, we have 4x over x minus 1. And it's equal to 4x over 2x plus 2. I'm working from an old edition, just making sure this is what you have. Okay. Going back to this, if we didn't have all the variables and we were just looking for one piece of information, how would you solve this?
X minus 1 is equal to 2x plus 2.
Ah, so you notice that if the top are the same, the bottom have to be the same. Very, very similar. I looked at it as a cross multiply problem and then quickly came to the same solution of, oh, those are the same thing. And so he's saying, well, if the top is the same, the bottom has to be the same. And that's true. And so we solve x minus 1 equals 2x plus 2. Subtract an x from both sides and we get x. Subtract 2 from both sides and we get negative 3. The other possibility that would make this true is, well, no matter what x I pick, if this is 0 up here, 0 equals 0, and that would also be true. And so this is one solution. The other solution is that x equals 0, but it asks for the sum of the solutions. And so negative 3 plus 0, you're back to that negative 3. So that was the 28. 29 is back to the idea of absolute value. Absolute value just goes straight to the positive, no matter if it's positive or not. So negative 2, absolute value is 2. 2 squared is 4. Negative 5, absolute value, goes to positive 5. And then negative 3 is just hanging out. And so we have 4 plus 5 minus 3. 9 minus 3 equals 6. And then for 30, another one that I have marked. This one is a geometry tricky one. If you were fighting this on a test, it would be one of the ones I would circle and go back to and then see if you have time for it, because there's likely more problems that you can solve easier later on. But for me, what's going on is a lot of geometry. This marker's dying on me. I'll switch back to brown. We're told that XY and ZW are parallel to each other. So these angles are the same. And we're also told that they are bisected by AB. Bisected means that these are cut into equal pieces. And then we have the lengths of XY, YZ, and ZW are the same. But the tricky part is right in here. Because these are parallel, and because these are the same length, and these angles are the same, and these angles are the same, what happens is that these sides are also bisected. So that's the geometry trick to it. The final thing was, well, if these are the same, and these are the same, and these are the same, then these pieces that I said, well, those two are the same because it's also getting cut in half, now they're equal to themselves. And if this is the same and this is the same, then that angle is the same. It's back to isosceles. So yeah, that's one of the trickier geometry problems that I've seen for the ACT. It's well worth a question, but it ends up being, well, if this is 45 because this was 45, then this is also 45. And not drawn to scale, that's a right triangle. But yeah, that one's definitely worth asking the question about. It took me a couple of minutes of, oh, okay, that's what they want. All right, we will continue moving forward. Good questions. Start at 31 or wherever you are and go forward. All right, checking in again. 31 is C. 32 is F. 33 is C. 34 is K. 35 is D. Looking back at my notes. So 31 is solving. 32 is either Pythagorean theorem or special right triangles, depending on how you see it. 33, I don't know that we've talked about the center of circles yet. Has anybody got questions about that one? Yeah. So this one's really pretty simple, so it's a good one to talk about. We have x minus 2 squared, and we have, where'd it go? X plus 1 squared, or y plus 1, sorry, can't read. And this equals 4. So with the equations of circles, the important thing to know is that the center of the circle is going to be the x value that makes this 0. What x value would make that 0? 2. If x minus 2, or x minus 2 equals 0, then x equals 2. What y value would make that 0? Negative 1. And so the center of our circle is at 2, negative 1. Not scary, you just haven't done it yet. The other thing to be aware of is that this number equals the radius squared. So if that number equals 4, what's our radius going to be? Just 2. Square root of 4. So radius equals 2. Again, not something that you've done before, but just by having exposure to it, it's not hard, it's just new. They can get more complicated than that, but frequently they keep it at this surface level. All right, that was that one. 34. How many of you got this right? So this is one that I actually got wrong when I was practicing. I was mistaught. Even a natural number are the counting numbers like 1, 2, 3 to infinity, but even still, it is a complex number. A complex number is anything that can be written as some number plus some other number times I. And even if we add these two natural numbers together, I'm going to pick 3 and 7. 3 plus 7 is 10. But 10 could be written as 10 plus 0i. And so it's still technically a complex number. And it messes with my head because that's the most boring complex number I've ever heard of. I thought complex numbers had to be more, complex. But no, technically it belongs to the complex number system, even if it's a normal old natural number. So it belongs to all of
What's
it.
a rational number again?
Huh?
What's a rational number again? I forgot.
Rational is one that can be written as a fraction. So again, back to my example of 10, it's a rational number because 10 can be written as 10 over 1.
Okay, thank you.
Good double checking. Anything else on that one? In general, you don't see a lot of the number system numbers, but there's usually at least one. So good double checking on the rational and complex is one that tripped me up. And then 35, it's a matter of recognizing, if I have 5 households with 2 TVs, that's going to be a total of 10 TVs. And so working with that back door to getting your numbers. All right. We've got time for about 2 more sets, I think. So go ahead and start with 36 through 40. if you have not already. All right. Checking in on 36 through 40. 36 is H. 37 is B as in boy. 38 is J. 39 is A. And 40 is K. looking at those questions very quickly. 36. It's a matter of finding the differences of those two areas. Notice they leave it in terms of pi, and that's pretty normal. On 37, I would drop myself a very quick graph and just work backwards with that slope. 38 is a weird one. That one could take you a long time if you had to solve all of those, and so I tried to ballpark solve to begin with of, hey, is that x reasonable, or is my x going to be greater than, and double check there, and then go forward. 39, the picture really does not help. That graph means nothing. Just work with the coordinates and find the slope. Doesn't have enough detail to work for anything. And then 40 is plugging in. All right, on 41 through 45, 45 is one that I don't think you guys know yet. And so if you know it, great. If you don't, feel free to just skip that and move on. And again, getting used to the idea of that's something I can't do, I'm gonna skip that and move forward is okay. So working with that feeling, we will take an additional 5 minutes. Alright, checking in once more. 41 would be E, 42 F, 43 D, 44 G, and 45 A. So, talking about 45 just for a second. Again, this is something that you haven't met before, but a sine wave is something that just oscillates like this. And if we have a standard sine wave, what's going to happen is it's going to complete the period or go back to where it was at the very beginning and start over at 2 pi. Back to the idea of the circumference of a circle is what it ends up tracing out. But if we multiply by 2, it ends up going twice as fast. And so it will go both up and down at halfway, or a single pi. And so it asks when it's reaching its maximum, this point, that's going to happen if this is the middle, this is 1/4, or pi divided by 4. So that's what's going on with those. You haven't learned it yet. That's okay. 46, I actually want to talk about because this one is more interesting. There are 2 ways to do this. One of them is to just plug in a couple numbers and see. And the easiest numbers to plug in are actually 0. Pretend that y is 0 and x is 0, or sorry, y is 0 and that should be z. If y and z are both 0, what happens with 7? It just stays 7. And so if both of these were 0, this would just equal 7. And now they ask us, what happens if the value of x, or sorry, if the value of y decreases by 2 and the value of z is increased by 1? Well, all of a sudden we're going to have 0 decreased by 2 is -2. So 3 times -2 minus 4 times increased by 1, so 4 times 1, and then plus 7. Well, the 3 times -2 is going to give us -6, and then we're subtracting 4 more and adding 7. So -6 minus 4 more is -10 plus 7 equals -3. So from 7 to -3, what's our change? Is it increasing or decreasing? First question. It's definitely decreasing. And so it decreases by 10. If we take 7 and minus 10, we get to -3. And so that is the J option. It decreases by 10. So sometimes it's easy to just plug in numbers and then make the change they ask. Well, what if this change happens? Well, that's how much it changes. The other thing you can do is say, okay, if y decreases by 2, this one is going to go down 2 times 3, or -6. If this increases by 1, we're going to be subtracting 4 and more, and that's -4. -6 minus 4, -10. So those are the 2 ways to approach that one. Anyone who worked ahead and has any questions from the rest of the test? There's a lot of sine and cosine on this one. And that was it for as far as ones that I really wanted to talk to you about. All right, take a 2-minute break and then we will regroup for next section.